Jason's buying a pair of jeans at the Gap. The jeans are $80 but are 35% off. What's the discounted price? What's the cost after tax? So first thing I'm going to do is I'm just going to draw my $80 here. And that's going to represent 100%. So there's my $80. There's my 100%. And they're 35% off. So when we talk about our multiplying factor, we want to use our multiplying factor. So although the percentage is 35, we want to multiply 80 by 65%. So we're going to pay 65%. So our multiplying factor is going to be times by 0.65. And that's going to represent 65% of our original. So I'm going to draw that maybe about here. That's 65%. Okay, so this is my discount. I'll just highlight my discount. This represents my 35%. Okay, so that's my 35% off. But that's not what I want to use my multiplier as the part that I have left over. That's the part that I'm going to pay. So we subtract 35% from 100 to get our 65%, and we're going to use this 0.65 as our multiplier. So multiplying by 0.65, $80 times 0.65 gives us $52. So that represents $52. So the portion that we get charged is $52. And that represents $52 is 65% of 80. So this is a portion that I paid. This is a portion I'm being charged. So that is the discounted price. So that's part A. So the discounted price is $52. The price after tax, well, we have to pay 12% tax. So 12% tax on top of the 65 is going to be, I'm going to just draw that right about here. And this is going to be 12% of 65%. So our multiplying factor for 12% is we're going to use 112%, because that's what we're going to end up with. We're going to end up paying 112% of the $52. So this portion right here represents, I'm going to write it out here, that blue line represents, we start with 65% and we want 112% of the 65%. Okay, this is our tax price right there. And so when I multiply that together, I'm going to multiply $52 times 112%. And I'm going to end up with 58. This represents this multiplication. It's not $58, but the position is going to be $58.24. So $58.24. Now, some people may calculate the tax, the 12% separately. Okay, that 12% in here might be calculated separately. So some people do 52 times 0.12 and figure out that they're paying $6.42 of tax and add it on. My suggestion is, instead of adding on, we try to keep everything as multiplying. We just use our multiplying factors. So once we figured out our $52, our multiplying factor for 12% tax becomes 112%, because we want to have our original amount plus the 12%, and this multiplication gives us the total amount after we add on the tax. And I'm not adding on, I'm using a multiplier. And the reason why we want to do that is because it keeps the math simple, because we want to keep this all as multiplication division math and not worry about all these plus pieces involved here. So if we can work out our multiplying factors, in this case we use 65% and 112%, that makes the math calculations of this much easier. The average Canadian pays 44% of their gross income in taxes. What does a person's income need to be if they are to be able to spend $40,000? So the $40,000 represents the amount that they have. So I'm going to write this $40,000 over their income price. Income is the whole, so $40,000 is what they have after taxes. Now, I could use 44%. However, the 44% does not represent the amount that I get. It's amount that I deducted. So the amount that I actually have, I need to convert the 44% taken off into 56% that I have left over. So the $40,000 is not what I took off, it's what I have left over, so I have to convert that into 56%, and my income then becomes my 100% comparison. So once I've set up this ratio properly, I can then use that decimal multiplier. And I'm going in the opposite direction, so I'm going to divide by 56%. So 40,000 divided by 56% gives me approximately an income of about $71,000. And I'm going to round that to $429. Okay, so I get 71,428.57. So the key here is we have to make sure in these word problems to determine if the percentage is how much we have or how much we deduct. So we always want to try to use a percentage that we have. Now some people may have calculated what 44% is, and then that would have been the deduction, but that would be difficult to do. It's complicated. It would be very complicated because the $40,000 doesn't relate proportionally to 44%. It relates proportionally to the 56%. Here a person earns $35 of simple interest on a $500 investment over 2 years. So our simple interest formula looks like this. Our interest is equal to the principal, that's the amount we have, times the rate, times the number of years or the time. So here we've been given the interest, $35. The $500 is our principal. That's how much we start with. Okay, and I'm going to put in brackets here, this is our starting amount. The rate is, that's what we're trying to figure out. So we're trying to figure out the rate, and that's over 2 years. This just becomes an algebraic equation where we need to get rid of the times $500 and the times by 2. So if I want to get rid of the times by 500, I'm going to divide by 500, and I'm going to divide, to get rid of the 2, I'm going to divide by 2, and I need to do that on both sides. And what ends up happening here is the $500 cancels out, and the units cancel out, so I actually lose my units of dollars. So dollars and dollars cancel out, and what I'm going to end up with is my units are being gone, and that's just going to leave me with a percentage. So canceling this out here, times 2 divide 2 times 500 divide by 500, we're left with the rate. When I do this 35 divided by 500 divided by 2, I get 0.035. And what that means is my decimal rate is 0.035. So my percentage is 3.5% is my interest rate. And we can set up a proportion, but remember we have an easy way to convert decimal to percentage by moving that over 2 spots. So that's part A. I figured out my annual interest rate. For part B, I need to figure out how much simple interest will be earned in 10 years. Well, then I just plug it right back into this formula. My interest is what I'm calculating. I start with $500. My rate is, I'm going to use a decimal rate, 0.035, And this time, instead of 2 years, I'm going to do it for 10 years. So my simple interest becomes 500 times 0.035 times 10 years. And that's going to give me $175 worth of interest over 10 years. Okay, that really means, translates to about $17.50 every year for interest. Now, this is how simple interest works, but bear in mind, the real world really doesn't use simple interest. It uses something called compound interest. But this is how simple interest works, and if we want to use simple interest, we essentially want to use this formula here. And we can calculate the interest using this formula. We can sometimes have to solve for the principal rate or time, and we do that by dividing out the parts that we know.